is our honors chemistry lesson video for section 12.3, and this is part 2. So we are going to continue talking about limiting reagent problems. And in this video, we are just going to explore some of the other possible things that they can ask, just besides how much product are you going to produce and which one's the limiting. Sometimes they may then ask you for how much of a different product is produced, or they may ask how much excess reagent is left over. And so I'm going to show you how to do those in this video. So let's go ahead and get started. So it says a mixture of 1.5 moles of aluminum and 3 moles of chlorine is allowed to react. Here's our reaction. Then it says, which is the limiting reagent? Now notice it doesn't actually tell me, like what are we going to? Are we trying to figure out, are we trying to figure out grams? Are we trying to figure out molecules? What are we looking for here? So I can see this is part A, so let me just click to the next slide real quick just to see what part B is. So part B says how many moles of AlCl3 are formed. Okay, so now that I can see part B, I'm going to put a mole and a question mark here, just so I know that's what I'm trying to go to. I know clearly this is the only option as a product, but I just wanted to know what am I trying to solve for. Okay, so in the process, I can figure out which one is the limiting reagent. So I need to start with aluminum and go to my product, then start with chlorine and go to my product, and then remember we always pick the lowest because that's when the limiting reagent runs out. So I'm going to start with my aluminum. So I have 1.5 moles of aluminum. And so step 1 is to convert to moles. However, I already have moles, so I can skip step 1. Step 2 is mole ratio. Remember, as long as you're going from one substance to another in a reaction, you cannot skip the mole ratio step. So I can see that 2 moles of aluminum makes 2 moles of aluminum chloride. Because moles of aluminum is on top, I'm going to put the 2 moles aluminum on bottom and the 2 moles aluminum chloride on top. So see, now I've switched over to the aluminum chloride. Step 3 is to convert to unit asked for. Well, it asked me for moles of aluminum chloride. Well, if you look, I already have moles of aluminum chloride, so I'm done. I multiply and divide, which clearly gives me 1.5 moles of aluminum chloride. Now, I don't know if aluminum is the limiting reagent or if aluminum chloride is how much I'm going to create at this point, because I still have to check with my chlorine. So I'm going to start with my 3 moles of chlorine. Step 1 is convert to moles. However, again, I already have moles, so I don't have to do that step. Step 2 is mole ratio. So now I can see that 3 moles of chlorine makes 2 moles of aluminum chloride. Since chlorine is on top, I'm going to put my 3 moles of chlorine on bottom and my 2 moles of aluminum chloride on top. So see, now I have successfully gotten to aluminum chloride. Then step 3 is to convert to unit asked for, but remember it asked me for moles of aluminum chloride, so I don't need to do that step. So I multiply and divide, and for this one I'm clearly going to get 2. Alright, so once you have your 2 amounts, then it says what is the limiting reagent. So remember, the limiting reagent makes the lower amount. So see, I have 2 and 1.5 to pick from. So that means aluminum will be my limiting reagent because aluminum made the lower amount of aluminum chloride. Now part B says how much aluminum chloride is produced. Well, that would be this right here because remember, you pick the lowest. Alright, so for part B, there's my answer. Since it's on the next slide though, I'm just going to box it on here. So this was my answer for part A, and this was my answer for part B. Alright, so let's move on and look at what part C asks us. Alright, so like I said, we decided that was our answer in part B. So then it says how many moles of the excess reactant remain at the end of the reaction. Okay, so we decided that aluminum is the limiting. Okay, this is from the previous slide. So that means that our excess was chlorine. If you go back, you'll notice that we started with 3 moles of Cl2. Okay, so you have 2 options for how you can figure out how much was actually used. you can start with your starting amount of aluminum, which was the 1.5 moles of aluminum, and go to Cl2 to figure out how much was used. Or you could start with the fact that you know we made 1.5 moles of aluminum chloride. Either one will work. Like the next couple of slides, there's multiple different ways you can solve for this. Alright, so what I did was I started with the aluminum. Since I knew aluminum was the limiting, I started with that. So what I did was, here, let me put our reaction down here real quick. Alright, so what I chose to do was say, okay, I know I have 1.5 moles of aluminum. How many moles of chlorine would I need to do that reaction? Okay, because we know that aluminum is going to run out after 1.5 moles. Alright, so I start with my 1.5 moles of aluminum. My first step is convert to moles. However, again, I'm already there, so I can skip that. My second step is mole ratio. So this time I'm going from aluminum to chlorine. So I can see that 2 moles of aluminum needs 3 moles of chlorine. Since I have moles of aluminum on top, I put the 2 moles of aluminum on bottom and the 3 moles of chlorine on top. So step 3 is to convert to unit asked for. However, I'm just looking for moles. So I'm already at moles of chlorine, so I can stop. So I just multiply the top, divide the bottom, and so I get 2.25 moles of chlorine. Now this isn't the answer to this question. This is how much was actually used. Okay, because in order for the 1.5 moles of aluminum to react, it needs 2.25 moles of chlorine. So that's not how much is left over. I started with 3 moles. That's how much I used. So I need to subtract to get how much is left over. So I do my 3 moles minus my 2.25 moles. And then I end up with, of course, 0.75 moles of chlorine. And that is my excess. Okay, so that's the important thing to note, is right here, I didn't calculate how much I had left over. I calculated how much did I need to react with the aluminum. So then to figure out the excess, I had to take what I started with in the very beginning of the question, and I subtracted what I used. Alright, so we just did an example with kind of some extra questions where it was real easy, it was just moles to moles. So now let's do some where we can't skip quite as many steps, just to make sure that you can, do even the full 3 steps. The basic 3-step stoichiometry problem is the backbone of this whole chapter, so you've got to get good at doing that. Skipping steps is always nice, but you got to be able to do the basic, all the steps. Alright, so our next one, it says, suppose a fuel cell is set up with 150 grams of hydrogen gas, so we have 150 grams, and 1,500 grams of oxygen gas. How many grams of water can be formed? Alright, so I'm going to have to go from here to here to get how many grams? From here to here to get how many grams, and then of course I'm going to pick the lower of the 2. Alright, maybe pause the video and try this one on your own if you haven't been trying any. Otherwise you can wait until we get to one of the harder ones. The next one we're going to do is probably the hardest. So maybe pause it and try this one first, and then I'll do the hardest one for you. Alright, so I'm going to go ahead and start with hydrogen. So I have 150 grams of hydrogen. And so my first step, of course, is to convert to moles. Since I have grams, I'm going to use molar mass. So for hydrogen, it's 1 times 2, so 2 grams per mole. So because I have grams on top, I'm going to put my 2 grams on bottom and my 1 mole on top, because molar mass, of course, always equals 1 mole of the substance. Step 2 is mole ratio. So I can see that 2 moles of hydrogen makes 2 moles of water. But since hydrogen's on top, I'm going to put the 2 moles of hydrogen on bottom, making 2 moles of water on top. So my moles of hydrogen cancel, and now I've successfully gone over to water instead. Then step 3 is to convert to unit asked for. Well, this time they asked me for how many grams of water. So since I need grams, I'm going to do molar mass, but because I have now switched over to water, I'm going to use molar mass of H2O. So molar mass of H2O is 18 grams per mole. Since I have mole on top, I'm going to put the 1 mole on bottom, and that equals 18 grams on top. So my mole cancel, and so then I multiply across the top, divide across the bottom, and for this one I ended up getting 1,350 grams of water. Now, I don't know if that's the amount of water I'm actually going to create or not because I haven't checked oxygen yet. All right, so let's look at oxygen. So now we're going to start with our 1,500 grams of oxygen. And so step one, of course, is to convert to moles. Well, since I have grams, I'm going to use molar mass. So oxygen 16 times 2, or 32 grams per mole. So since I have grams on top, I'm going to put my 32 grams on bottom and my 1 mole on top. Step 2 is mole ratio. All right, so I can see that 1 mole of oxygen makes 2 moles of water. Since moles of oxygen is on top, I'm going to put my 1 mole oxygen on bottom and my 2 moles of water on top. So my moles of oxygen cancel. And then last step is to convert to unit asked for. Well, again, I asked for grams of water. Well, remember, in a limiting reagent problem, I just did grams of water right here, so I can reuse that same step. So 1 mole of water is 18 grams. So my moles cancel. So see, now I got to grams of water, which is what it's asking for. And so when I solve, I got 1,687.5 grams of water. So how much am I actually going to be able to produce? The lower amount, because once I get to 1,350 grams of water, I'm going to be out of hydrogen. So even though it didn't ask this, if it had asked for limiting and excess, remember, limiting makes the lower amount. So my limiting reagent will be hydrogen, and excess makes the larger amount. So my excess reagent would be oxygen, just like that. All right, so hopefully if you tried that one on your own, you got it right. Okay, so let's move on to just one more example where we're just kind of having to solve for everything. We're using all the steps. We're solving for everything in the whole reaction. So this one, I'm not going to lie, is kind of long. But it's okay. If you can do this one, you can do all of them. All right, so it said a strip of zinc metal with a mass of 2 grams is placed in an aqueous solution containing 2.5 grams of silver nitrate, causing the following reaction to occur. Which reactant is limiting? Okay, now this time I do have 2 products, so I don't even know, like, is it going to ask me to solve for a specific product? So again, I can see that this is just one part to the question, so let's check and see what part B says. Part B says how many grams of silver will form. All right, so at least now I have a place that I'm going to. All right, so we're starting with grams. We're trying to get to grams. Ooh, I have a limited amount of space to work with here. All right, so first step is I'm going to go from zinc to my product. I'll go from silver nitrate to my product, and then of course I'll figure out which one's limiting, because which one made the lowest amount will be limiting. So I start with my 2 grams of zinc. So step 1 is convert to moles. Since I have grams, I'm going to use molar mass. For zinc, it's about 64. Oh, sorry, it's about 65, because zinc is 65.39. So it's about 65 grams per mole. Since I'm starting with grams, I put my grams on bottom and my mole on top. Second step is mole ratio. So I can see that 1 mole of zinc makes 2 moles of silver. So I'll put the 1 mole of zinc on bottom so I can follow the golden rule, and the 2 moles of silver on top. Third step is convert to unit asked for. Well, it asked me how many grams of silver, so that means I need to use molar mass. But this time I'm using silver instead of zinc, because zinc's gone. All right, so silver has a mass of about 108 grams per mole. Since moles are on top this time, I'm going to put the 1 mole on bottom, and that equals about 108 grams for silver. So my moles cancel. So then I just multiply across the top, divide by the bottom. And so for that one, I ended up getting about 6.65 moles of silver. Now again, I don't know if that's the right answer yet, because I haven't checked with the silver nitrate. Okay, so I gotta keep going. So I'm gonna start with my 2.5. Oh gosh, I don't even know where to write this at this point. I'll just write it down here. I hope y'all can see this. So we have 2.5 grams of silver nitrate, AgNO3. So our first step is convert to moles. Well, I have grams, so to get to moles, I'm going to use molar mass. When you add up AgNO3 on the periodic table, you're going to get about 170 grams per mole. Since I have grams on top, I'm going to put the 170 grams on bottom and the 1 mole on top. So my grams cancel. Step 2 is mole ratio. So I can see that 2 moles of silver nitrate make 2 moles of silver. So since I have silver nitrate on top, I'm going to put the 2 moles of silver nitrate on bottom and the 2 moles of silver on top. So my moles cancel. Now I've officially switched over to silver. And so then, of course, last step is convert to unit asked for. Well, I asked for grams. So remember, this is the time where you can reuse this step right here. Okay, you can just reuse that step. So I'm going to put my 1 mole of silver on bottom and my 108 grams on top. And so then I just multiply and divide. Let's see, so when I did that, I got 1.59 grams of silver. So now that I can see my 2 answers, I can see that this, whoops, I'm sorry, this should have been grams. Sorry, I just noticed that when I was about to compare the 2. Remember, your unit and substance come from right there. I can see that 1.59 grams is the lower of the 2, so that means my limiting reagent or reactant is AgNO3. Because the limiting is whatever makes the lower amount. Alright, I can also see that part B said how many grams of Ag will form, and so that is this right here. So this is my answer to part A, this is my answer to part B. Okay, but I can also see that there's a C and a D here too, so we'll get to that once I click. Alright, so let's move on. Maybe even pause it, like you can pause in the middle and try C and D on your own. And then we'll look at it together. Alright, so we decided that was how many grams of silver would form. Then it says how many grams of zinc nitrate would form. So now it's asking me about my other product. So just so that we have it, let me rewrite our reaction up here. Alright, so here's our reaction, just so that we have our coefficients. Now, you have options of how to calculate this. You could start with the fact that you know we're going to make this much silver and go from that to zinc nitrate. Or, since we decided that silver nitrate was our limiting reagent, you could start with silver nitrate and figure out how much zinc nitrate. The thing is, you can't start with zinc. That's the excess reagent. Once you determine the excess, you can't figure out anything else from that one. Okay, so what I chose to start with was I started with my silver nitrate. The reason I like to start with that is because I might have made a math error at some point in here. So if there was a math error in this, I can still get this one right if I start with the number that was given to me. So just be aware of little things like that. So if you remember, they told us we had 2.5 grams of silver nitrate, and so now we're trying to get to grams of zinc nitrate. So in other words, we're just going from here to here. So just a basic stoichiometry problem again. So I start with my 2.5 grams of silver nitrate. And my first step, of course, is to convert to moles. Since I have grams, I'm going to use molar mass. And so as we already know, the molar mass of silver nitrate is about 170 grams per mole. So since I have grams on top, I'll put my 170 grams on bottom and my 1 mole on top. So my grams cancel. Step 2 is mole ratio. So I can see that 2 moles of silver nitrate make 1 mole of zinc nitrate. Since silver nitrate's on top, I'll put my 2 moles of silver nitrate on bottom and my 1 mole of zinc nitrate on top. Just like that. Alright, and then last one, step 3, convert to unit asked for. Well, again, it asked me for grams. I know we're focusing on grams a lot. They could ask you for molecules, liters, or even just moles and let you skip some steps. But because grams involve the most calculations, I ask that a lot to make sure you know what you're doing. So I got to convert to unit asked for, which is grams of zinc nitrate. So when you add up zinc nitrate on the periodic table, you get about 189 grams per mole. So since I have mole on top, I'll put my 1 mole on bottom, and I'll put my 189 grams on top. So my moles cancel. I've gotten to grams of zinc nitrate, which is what it has asked for. All right, so I multiply the top, divide by the bottom, and so when I did that, I got 1.39 grams of zinc nitrate. Just like that. All right, so last one, it says how many grams of the excess reagent will be left? So remember, we decided that silver nitrate was the limiting, and so that means zinc was the excess. So again, you could start with so many different things. You could say, I know I'm going to make this much silver, so let me figure out how much zinc I needed. Or you could say, I know I'm going to make this much zinc nitrate. Let me see how much zinc I needed. Or you could say, I know I started with 2.5 grams of silver nitrate, and that's going to be fully used up. Let me see how much zinc it's going to take. So there's 3 different ways you could tackle this part. Okay, I chose to start with, again, the silver nitrate. It's always best, if possible, to start with one of the numbers that's given to you. Because like I said, if for some reason then you made a math error, you don't want to then use your incorrect answer to keep going. Okay, so I'm still going to focus back on the fact that I know for sure we had 2.5 grams of silver nitrate. Okay, so if you remember in the question, we started with 2 grams of zinc. Okay, so for my zinc, I started with 2 grams. All right, so that's how much I had to start. So we're going to start with our 2.5 grams of silver nitrate that we know we used up, and we are going to go to zinc to figure out how much did we need to react with the 2.5 grams of silver nitrate. So I'll start with my 2.5 grams of silver nitrate. So of course, first step is change to moles, but if you look, y'all, we just did that right here. Okay, I'm not going to lie, this is kind of the never-ending problem. So I put 170 grams of silver nitrate, and that equals 1 mole. I put the grams on bottom, of course, to follow my golden rule. So grams cancel. Step 2 is mole ratio. So I can see that 2 moles of silver nitrate needs 1 mole of zinc to react. I put the silver nitrate on bottom because, of course, I'm following my golden rule. And of course, that needs 1 mole of zinc to react that I'll put on top. So my silver nitrate cancels. So see, now I've officially switched over to zinc. Step 3 is to convert to unit asked for. Well, I know how many grams I started with, so I obviously want to convert to grams too. So I need to use molar mass. And so for zinc, that's about 65 grams per mole. So since mole's on top, I put my 1 mole on bottom and my 65 grams on top. So I multiply across the top, divide across the bottom, and I get 0.48 grams of zinc. Now remember, this is how much we used. This is how much we needed to react with that 2.5 grams of silver nitrate. So 0.48. Remember, we started with 2 grams. So I take my starting amount, 2 grams, and I subtract how much I used, 0.48 grams. And so once I subtract that, I get 1.52 grams of zinc, and that is my excess. Okay, so really for limiting reagents, you just need to pay attention. Where am I starting? Where am I going to? Are they asking me which one's limiting? Are they asking excess? Are they asking for a product? And so that's why you'll see me all the time labeling things on the reaction, because it kind of helps you keep everything in check of where are you starting, what are you going to. But otherwise, like I said, the backbone of everything is the 3-step stoichiometry problem. So the faster and better you can get at this, the easier everything else will be.